Hello, in today's video we're going to talk about problem 106 from the Calculus AB BC Summer Review Packet. So this problem is about a hypothetical rectangle. They want us to express the area of the rectangle as a function of the length of one of its sides, and they tell us that the perimeter is 20. And do they give us units? Meters, but that doesn't really matter to the story at all, does it? So figure rectangle. Okay, that looks more like a square, but it's rectangle. And let's say we have length, width, and width. Then you would get the perimeter by adding up all four of those sides. So length plus width plus length plus width equals 20. Now they want us to express this in terms of length, and so I'm actually going to solve it for W, and you'll see why in a second. So this would become 2L plus 2W equals 20. Take the L and move it over to the other side, so minus the 2L, and we get 2W equals 20 minus 2L. And then we have to divide everything by 2. And we get W equals 10 minus L. So then what we're going to do is we're going to use that to figure out the area. But give me just a second to erase my board. So the width equals 10 minus the length. And now what we want to do is we want to figure out the area of this rectangle. So we know that area is width times length, or length times width, depending on how you say it. And we can see that our width, we can substitute in 10 minus L. So we get 10 minus L times L. You could say it like that, or if you wanted to, you could distribute this in, and you could get negative L squared plus 10L. And that is your area of your rectangle. So we have our area being negative L squared plus 10L. And so now you can see why we solved for W in the first place, because that's what allowed us to actually end up by substituting into the W. We got rid of the letter W, and now everything is in terms of L, or in terms of length, which is what the question had asked for. We do have to restrict the domain. If you were to graph this here, you would get a little picture that looks something like this. The intercepts are at 0 and 10. The max is at 5, 25. So that's saying when the length of the rectangle is 5, the area of the rectangle is 25. It's basically a perfect square at that point. And then here's the area going up and down. You know, it goes from like a little bit of area up to 25 square meters down to just a little bit of area again. So what we want to do is we can't have negative area and we can't have negative length. That doesn't make any sense. So we wanted to restrict our domain. Now in the answer key, it says to restrict your domain from 5 through 10. I don't see it that way. I see it as you want to restrict your domain between 0 and 10, because that keeps you with positive dimensions for your length and width, and it also keeps you with a positive number for your area. So I would say that the length should be in between 0 and 10, but not including those numbers. The only thing that I can figure for why they put it between 5 and 10 is because if you figure length has to be longer, then you would want it on the longer end of these numbers. But that's a little ticky-tack. I think that your domain should be kept in between 0 and 10, but not including those numbers. Thanks for watching. If you want tutoring this summer, or if you're going to need tutoring during calculus for the school year, contact me. My contact information is at the end of the video and also in the description down below. Thanks for watching.